Initiating virtual tour.
And we are live!
Actually, this is pre-recorded.
Hello there! You made it! Welcome to the virtual tour of the University of the Philippines, Cebu. I'm Annie, and I am a proud alumna of UP Cebu. And between just you and me, I had the best 4 years here in UP Cebu. I came from the College of Communication, Arts and Design, where we did not learn only the basics in journalism and other communication components, but they also taught us how to become relevant.
You only have one viewer.
My college is also home to the fabrication laboratory, where people meet and converge to use different equipment where they can fabricate things, stuff for the advancement of industrial and product design. All of this comes from the creativity of the Fine Arts program itself. Hey Sean, why don't you tell them more about the Fine Arts program?
The Fine Arts program itself, founded in 1975, is the pioneer formal school in the fine arts outside the national capital. The college is also the host to nearly half a century-old annual painting competition, Jose Joya Awards, in honor of the famous national artist Jose Joya, and from whom UP Cebu's Jose Joya Gallery was named after.
As the campus of the premier university here in the Visayas, we have to be good. No, we have to be better, or even we have to be the best, not only in the humanities, but even in the sciences as well. Isn't that right, Sean?
That's right, Annie. In 2014, UP Cebu CENVI, or the Central Visayas Center for Environmental Informatics, came up with high-resolution maps using LiDAR technology. The use of this technology by UP Cebu CENVI provided government agencies with accurate data for more precise community flood risk assessment and management. This helped local government units make informed decisions based on data science and, in the process, maximizing their financial resource utilization. And in the case of the Naga Cebu landslide of 2018, UP Cebu CENVI's use of LiDAR technology allowed for one of the fastest search and retrieval operations in a disaster in the Visayas.
Helping the community through the sciences is very fulfilling. But we were not just exposed to that. We were also exposed to the social sciences, from political science to psychology, and all of these concepts helped shape our mindsets to become better citizens. In fact,
the College of Social Sciences articulates and addresses global challenges. The college offers comprehensive and appealing programs for high school, undergraduate, and graduate students. The Master of Education program is a non-thesis graduate program designed for graduates of the Bachelor of Elementary Education or Bachelor of Secondary Education who want to pursue their professional preparation through future studies in areas relevant to teacher education.
And of course, there were also budding business leaders in campus. They were the ones who had the nose for business but had the big heart to be of service.
Under the School of Management, students are not only taught to be decision makers, but the forerunners in marketing and finance. It also hones those interested in further studies of this field through its Masters in Business Administration program.
Today, I am now a practicing broadcast journalist, an opinion columnist, an entrepreneur, a teacher, a better person, really. All of this because of my training and experience at UP Cebu.
Nurtured to create, inspired to innovate, destined to serve. We at the University of the Philippines Cebu are driven by academic and operational excellence.
And that's it. Thank you so much for joining this virtual tour. I'm so happy you took part. Oh, look, Sean, a lot of people are tuning in.
But the tour is over.
Well, we'll just do it again.
Ready when you are, Annie.
Reinitiate virtual tour.
Good afternoon, everyone. I'm very happy to see everybody right now, and we are happy to welcome you to our little offering from the island of Cebu. UP Cebu's DLRC has envisioned a border-free and cost-free learning for everyone of all ages. In today's session, we would look like, to learn more about statistics. And if you are part of the last session that we have on the introduction on Likert data analysis, you will be very glad to have our part 1 of inferential use of these Likert data analysis today. This is the second of the 3-part series, and thank you for being here with us. I would like to know where our attendees are coming from. Noel, are they allowed to give answers in the chat box?
I think so, yes.
Okay, so let me know where you came from. I'm currently at Laguna right now, at Los Baños, at the foot of Makiling near UPLB. And I do know that a lot of us are coming from the National Capital Region here in NCR, and most are coming also from Mindanao. And hopefully we have more than enough number of participants from the Visayas. So before we start, we have some people coming from QC, Bulacan, and Agusan del Sur, Mindanao. So as you can see, we have a lot of representatives coming from the different parts of the Philippines. Thank you for being here with us. Now,
Miss Gerald?
Yes, Noel?
I would also like to shout out Sir Mike. He's watching right now.
Or Mike! We
Via
miss you
YouTube
so
Live.
much. He's at the YouTube Live. We also have some participants coming from Northwestern University at Lawag City, Ilocos Norte, and from Agusan del Sur. Sige lang, if the chat is disabled, you can use the Q&A chat box. Michael, how are you? We are so happy to have you with us, and I do know you are now teaching, so happy teaching. Education is the key. Okay, starting off. Now, welcome to UP Cebu's Teaching and Learning Resource Center webinar series. Today is March 1 and the official start of the Women's Month. Happy Women's Month, Miss Natty and Noel. And what is the best way to celebrate our Kaiska at Kababayinan is to start with learning. And starting with learning in various fields. Starting off this year's series are the handsome and definitely awesome professors at the mathematics program of UP Cebu's College of Science. We'll be taking a look at one of the most useful tool and method in academic research, Likert scales. Whether you are a budding student or a researcher or a seasoned teacher, this series will likely make you like Likert research more. Before the webinar proper, I would like to enjoin you to listen to Ms. Noel for our webinar netiquettes, to our beloved TLRC coordinator, Ms. Nati, for the introduction of the speaker, and of course to our very own speaker coming from the mathematics department. Noel, take the stage.
Thank you, Ms. Gerald. Okay, so before we proceed with our webinar proper, please don't forget the following webinar reminders. So this webinar will be recorded. We will be keeping tab of the proceedings for this webinar for our documentation purposes. You are free to leave if you feel uncomfortable that this session will be recorded. And please mute your microphone during the talk. We want to make sure that the speaker's voice is clear to everyone. We may opt to remove you if you don't follow this request. And also, please refrain from taking pictures or videos of the talk. If you do so, you will be held accountable of data privacy violations if the copy you created leaks into other internet outlets. We wish to keep the identity of our participants private, so is yours as well. And please avoid using the annotation tool. Once the annotation tool is activated, you might unconsciously swerve your arrow towards the speaker's presentation and draw unnecessary lines that may block the participant's view on some text and images on the slides. If you have questions while the talk is ongoing, you may put them in the Q&A box. After the talk, you will have a chance to ask your questions, and we wish for you to only use the Q&A box rather than voice because of our time constraint. And don't forget to evaluate. Your inputs on the webinar will help us improve our next webinars. After you have answered the forms, you will be given a proof of participation. The evaluation link will be opened right after the webinar and shall remain open for only 10 minutes. And we are currently live streaming on our YouTube channel. For those watching through YouTube and were registered, you will get your proof of participation by staying until the end of the session. We will be announcing the instructions at the live chat, so please stay tuned. And for those who are registered already and are currently on our YouTube, you can still join us here in the Zoom webinar. We have still a lot of slots available. And if you want to get more updates and webinar and training updates, you can follow and contact us on this platform. So our Facebook page is Teaching and Learning Resource Center, University of the Philippines, Cebu. And you can also subscribe to our YouTube channel where you can watch our previous webinars, TLRC UP Cebu, or you can visit our website, tlrc.upcebu.edu.ph, or you may send us an email for your concerns at lrc.upcebu@up.edu.ph. Ms. Jara?
Okay, so for more information about all of TLRC's activities, programs, and free learning sessions, always make sure that you tune in at our UP Cebu TLRC FB page. It's easy to find, and you just need one click to like it. Okay, before anything else, we would like to say hi to our other participants. Some are coming from Laguna, some are coming from Saudi. So we have international participants today. But before anything else, we'd like to continue with our program. Miss Nati, take the stage.
Hello, thank you, Ms. Jera. Okay, so good afternoon to all of you, participants and viewers. Our resource speaker for today's webinar is currently a statistics instructor in the Math and Statistics programs of UP Cebu College of Science. He earned his Bachelor of Science and Master of Science in Statistics degrees from both from Mindanao State University, Iligan Institute of Technology, or MSU-IIT. His research interests are in the fields of biostatistics and computational statistics, and he has published 2 research papers in the said fields. Aside from being in the academe, he is also enjoying being a volunteer of his LGU's Rural Health Unit. He is here with us today, this afternoon, to talk about analyzing Likert data. Specifically, he will discuss about different tests of association, independence, and correlation that we can apply in analyzing Likert data. And now, ladies and gentlemen, let me introduce to you our speaker, Mr. Joseph Pasaporte Abordo. Please give him a round of applause.
Good afternoon, Sir Joseph.
Good afternoon, Ma'am Jera. Thank you so much for that introduction, Dr. Nati. May I have the permission to share my screen now?
Yes, sir.
Okay, I hope that you can now see my screen.
Yes, sir.
Okay. Again, first, I would like to express my gratitude to the TLRC for conducting this webinar, to the host, Ms. Jera and Ma'am Noel, to my co-speakers, Professor Agustin and Professor Aboy, and to all the Zoom attendees. We have almost 700 attendees, no? and to the participants on our different social media platforms like YouTube. Okay, so for this afternoon, I am going to discuss the different inferences on Likert data. This is part one. So part two will be discussed by Professor Aboy. Okay. Last Wednesday, from the first webinar, Professor Agustin introduced the Likert data to us. Also, he taught us on how to visualize this data, Likert data. Okay. And for my talk, let's start with the correlation analysis. So basically, for this whole afternoon, I'm going to discuss correlation analysis only. Okay, for the comparison between two distributions of the two paired variables that will be discussed by Professor Aboy in the next and last webinar. Okay, let's first have a brief history of correlation. So we have here Sir Francis Galton in 1911. So he pioneered correlation. Also, he is a cousin of Charles Darwin. So he did a lot. He studied medicine, he explored Africa, he published in psychology and anthropology, he developed graphic techniques to map the weather, and others. Oops. Now, in 1877, Galton unveiled regression, and this is the earliest ancestor of correlation. In Galton's subsequent writings, reversion evolved into regression. And it was in 1888 that Galton first wrote about correlation. Okay. We also have Sir Carl Pearson in 1936. So Carl Pearson, Galton's colleague and friend, and father of Egon Pearson. He pursued the refinement of correlation with such vigor that the statistic R, a statistic Galton called the index of correlation and Pearson called the Galton coefficient of reversion, is known today as Pearson's R. Now, the first question for this afternoon will be, what is a correlation analysis? So a correlation analysis is it examines the linear relationship between two variables. Let's say, based on this illustration, we have variables x and y. Okay, so correlation analysis examines the linear relationship between these two variables. Let's say, for example, is there a connection between the age at which a child speaks its first sentences and later school success? Now, if the correlation analysis shows that two characteristics are related, it can then be investigated whether one variable can be used to predict the other. Okay, and then in order to do this, we can use regression analysis. This could then mean that with a regression, school success can be predicted by the age at which a child speaks its first sentences. So basically, the difference between correlation and regression is that correlation analysis quantifies the strength of the linear relationship between two variables, whereas in regression analysis, it expresses the linear relationship in the form of an equation. Okay, those are the differences, or one of the main differences between correlation and regression. Now let's have this, the very famous Pearson's R, correlation coefficient. And this is defined as using this equation, where our xi's and yi's are values of x and y for observation, say I. And our x bar and y bar are the sample means of x and y. Now, by virtue of the Cauchy-Schwarz inequality, the value of correlation coefficient R can vary from -1 to +1. Now, if R is -1, then the observations fall on a straight line whose slope is negative. And if R is a +1, then the observations fall on a straight line whose slope is positive. So we have here the different strength of correlation. This is called the table of correlation. Now we can base the strength of our correlation in these descriptions. Let's say, for example, if we have computed R, which is between 0 and 0.19, we can say that we have a very weak correlation. If our R is between 0.2 and 0.39, we can say that we have a weak correlation. If the value of our R is between 0.4 and 0.59, we can say that we have a moderate correlation, okay? If the value of our R is between 0.6 and 0.79, we can say that we have a strong correlation. And for 0.8 to 1.0, we can say that we have a very strong correlation. Now, if we have positive values for our R, we can say that we have a positive correlation, no? Positively very weak correlation, positively weak correlation, positively moderate correlation, positively strong correlation, and positively very strong correlation. Now, if we have negative values for our R, we can say that we have a negatively very weak correlation until the negatively very strong correlation. So it really depends on the sign of our Pearson's R, correlation coefficient, okay? Now, Haldon-Acuglo in 2018 summarized the different interpretation of the different fields in research when it comes to the strength of correlation. For example, in the field of psychology, Haldon-Acuglo found out that for a correlation coefficient 1, they labeled it as a perfect correlation. Okay, for 0.9, 0.7 to 0.9, they labeled it as a strong correlation. It's either positive or negative. Okay, and also for the politics, they also have a different interpretation of their strength of correlation, and that is also the same case to the medicine. So if you want to, let's say, conduct a research, you really have to stick to your objectives. Okay, for example, if you are in the social science field or in the medicine field, it's safer if you base your let's say, strength of correlation table to the high caliber journal that are published and a high caliber publisher, for example. It's safer that you based your strength of correlation table to those published paper, no? Because it really varies from one field to another. But in statistics, we usually use this table, okay? So this is the point of this table, okay? The strength of your correlation really depends on your study. You have to make sure that you have enough related literature for you to really come up with a more precise table of a strength of correlation. And that is the study of Haldon-Acuglo in 2018. Now, usually in statistics, we measure 4 types of correlation, right? We have the Pearson correlation, very famous, the Kendall rank correlation, the Spearman correlation, and the point serial correlation. But in this lecture, we have to focus more on these two, the Kendall rank and the Spearman correlation, because we are considering a Likert scale data. So we will find out later why it's more appropriate to use the Kendall rank and the Spearman correlations. So let's have here this table, and this is by Chin Chong. This is by Chin Chong Joy Chow. So for this table, let's say we have 2 variables, paired variables, y and x. If our y variable is in nominal scale and our x variable is in nominal scale also, then we can use the phi correlation coefficient if both are naturally dichotomous nominal variables. We can use the tetrachoric correlation coefficient if both are artificially dichotomous nominal variables, okay? If both our variables are, again, in nominal scale. Now, if one of our variables is in ordinal scale and the other one is in nominal scale, then we have to use the gamma correlation coefficient. If our let's say first variable is in ordinal scale and the other variable is in ordinal scale, we can use Spearman rank order correlation coefficient. Okay. So again, based on the lecture of Professor Agustin last Wednesday, when we consider a Likert scale survey questionnaire, our variables there are all in ordinal scale. Okay. So if we compare to ordinal variables, we have to use Spearman rank order correlation coefficient. And in the case where we have a small sample size and we have many tied ranks, we can use the Kendall-Stowe coefficient. Okay, so these two are the correlation analysis that we have to use when we have a Likert scale data. Okay. Now, if the first variable is in ordinal scale and the second variable is in interval or ratio scale, we do not have an existing correlation analysis to that yet. Okay. Now, if our first variable, let's say y, is in interval or ratio scale, and our second variable is in nominal scale, then we can use the biserial correlation. And that is if x is artificially dichotomous nominal variable, and we can also use the point biserial correlation if x is naturally dichotomous nominal variable. If our first variable is in interval or ratio scale, and then our second variable is in ordinal scale, we can use the Spearman rank order still, okay? And we can use the Kendall-Stowe if we have a small sample size and many tied ranks. Now, if both variables are in interval or ratio scale, then that is the time where we can use the Pearson product moment correlation coefficient, or that is just the Pearson R, okay, Pearson's R. Again, we use Pearson's R if we have two variables that are in interval or ratio scale. In Likert data, our variables are in ordinal scale. That's why we have to use Spearman or Kendall's. Okay, we cannot use Pearson when we have ordinal variables or two ordinal variables. Okay, that is by Chin Chong Chow. Okay, let's proceed to correlation analysis of Likert scale data. In this case, again, we have to use Kendall-Stowe and Spearman because our data are in ordinal scale. So let's first have a brief history about Charles Spearman. So Charles Spearman was strongly influenced by the work of Francis Galton. Again, Francis Galton discovered correlation from the previous discussion, okay, that we had. Spearman developed the Spearman rank correlation in 1904. And we have here the computational formula for our Spearman correlation coefficient. And this is denoted by rho. And this is just equal to 1 minus 6 times 6 multiplied to the sum of all the square differences over n times n squared minus 1. N here is the number of observations. And D are the differences between the ranks of the corresponding variables. And you also have Kendall-Stowe, let's say, the one who invented Kendall-Stowe. Okay, the non-parametric correlation coefficient known as Kendall-Stowe was first discussed by G.T. Fechner and others about 1900s. Now, Maurice George Kendall, the one that is in this image right here, we have here the image source. You can check this out. Maurice G. or M.G. Kendall rediscovered independently Kendall-Stowe in 1938. And we have here the computational formula for our Kendall-Stowe. Okay, we have the number of concordant minus the number of discordant over 1/2 multiplied to n times n minus 1. Okay, again, when we have variables in ordinal scale, we have to use Spearman rank correlation or Kendall-Stowe correlation. Okay, you have to bear that in mind. Now let's discuss briefly what is Spearman rank correlation. Spearman rank correlation is a non-parametric test that is used to measure the degree of association, okay, between two variables. If you can recall, when we use Pearson's R, we are actually, let's say, testing the correlation between the two variables. Here in Spearman rank correlation, we are more concerned about the association between these two variables. Okay, the Spearman rank correlation test does not carry any assumptions about the distribution of the data and is the appropriate correlation analysis when the variables are measured on a scale that is at least ordinal. Okay, because some of the crucial assumptions when we use Pearson's R is that our data is normally distributed. We also have the assumption of homogeneity, no? And let's say equal sizes of sample size, equal sample sizes. Okay, those are some crucial assumptions when we use Pearson's R. Now, when we use the Spearman rank correlation, since this is a non-parametric test, we do not have to meet those assumptions. Okay, so it's safer to use the Spearman rank correlation, or it's more appropriate to use the Spearman rank correlation when our data is in ordinal scale. Let's have the different types of research questions a Spearman correlation can examine. First, we have here. Is there a statistically significant relationship between participants' level of education, let's say high school, bachelor's, or graduate, and their starting salary? If you can notice, for the first variable, we have educational attainment. And we know that this variable is an ordinal variable, okay? We have an ordering, or let's say a natural ranking of the sample points or elements. And then we want to compare that to their starting salary, okay? In this case, if we have this research question, we can use the Spearman rank correlation. For the second example we have here, is there a statistically significant relationship between horses finishing position a race and horses' age? Okay. If you can notice, the first variable is the horse position in a race. So this is in ordinal scale, okay? But for the second variable, the horse's age, that is in the interval or ratio scale, okay? That is in the ratio scale, in to be specific, because we have the absolute zero property, okay? Now, in this case, since we have an ordinal scale, ordinal variable and a ratio variable, then we can still use the Spearman rank correlation based on the table that we had explained, Nina. Let's go back. Okay. If we have one variable that is in interval or ratio scale and one variable that is in ordinal scale, we can still use the Spearman rank order correlation coefficient. Now, if our sample size is small and we have many tied ranks, we can opt to use the Kendall-Stau coefficient. Okay, we also have some assumptions here for the Spearman rank correlation. Assumptions of the Spearman correlation are that data must be at least ordinal and the scores on one variable must be monotonically related to the other variable. Okay, that is just that is the only assumption that we have for the Spearman correlation. Spearman rank correlation, okay, that our variables are in ordinal scale. Let's have this example. So this example is from Nagua, okay? You can check this author. For example, find the Spearman's correlation coefficient between X and Y. So we have here X values, no? 4, 7, 8, 5, 8, 12. We also have here for the second row, the Y values, 7, 6, 6, 4, 6, and 10. Now to answer this one, you have to keep in mind that first, we assign ranks to the X values and Y values. Now putting them in order from least to greatest gives us, we have rank 1 for the 4th scale, rank 2 for the 5th scale, rank 3 for the 7th scale, rank 4 for the 8th scale, rank 5 for the 8th scale, and finally rank 6 for the 12th scale 12. Okay, if you can notice, we have tied rank. We have tied ranks here for rank 4 and 5. Now we have to re-rank, okay, our values. In order to do that, first we have to assign, we have to re-rank, okay, the two 8 scales. Here, since we have two 8s and we have their corresponding ranks, rank 4 and 5, we just have to take the mean of the two ranks, okay, rank 4 and rank 5. So 4 plus 5, that is 9, divided by 2, that is 4.5. Now we have our updated ranking. Our 4th scale now is still in rank 1. Our 5th scale is still in rank 2. Our 7th scale is still in rank 3. Now for our two scales that are in 8, we have 4.5, okay? These are now updated. And then for the last rank, we have 12, okay? We have to re-rank our values if we have tied ranks. Okay, now let's repeat this process with Y values. Now putting them in order from least to greatest gives us, we have rank 1 for the 4th scale, we have rank 2 for the 6th scale, we also have rank 3 and 4 for the other two 6 scales, and then rank 5 for the 7th scale, and rank 6 for the 10th scale. Since we have tied ranks here, we have 3 ranks that are in tied. We have to take the mean of those ranks. Okay, we have rank 2, rank 3, rank 4, and divided by 3, that is 9 over 3, that is 3. Now we have updated our ranking. For rank 1, we still have the 4th scale. For this, the 3, 6 scales, we have updated the ranks. No, we have ranks rank 3 for the 3, 6 scales, and then for the 7th scale, we still have rank 5 assigned to it, and then for the last rank, we have 10th scale. Okay, we have now updated our ranking. Let's proceed to this table. Okay, now we have the X values. If you can recall, we have 4, 7, 8, 5, 8, and 12. And then if you can also recall the updated ranking of these X values, we have rank 1 for 4, rank 2 for 5, up to rank 6. Okay, so for the 4th scale, we have rank 1 and so on. Okay, for the Y values, we also have to indicate the updated rankings. Let's say for 7th scale, we have a rank of 5. Okay, and so on. Now, if you can recall the computational formula for the Spearman rank correlation, we have to compute first for the differences, okay, between these ranks. Now, for the formula, we just have to subtract the rank of the Y values from the ranks of the X values. For example, this one. For the first difference, we have here for the first X value 4, this is ranked as, this is rank 1, okay? And then for the first Y value, this is in the 5th rank. So 1 minus 5, that is -4. Okay, that's why we have -4 here. We also do that, we do the same procedure to the rest of the values. So 3 minus 3 is 0, 4.5 minus 3 is 1.5, 2 minus 1 is 1, 4.5 minus 3 is 1.5, 6 minus 6 is 0. Okay, these are now our differences. Now, if you can recall from the computational formula of the Spearman rank correlation, we have to square first our differences in order to substitute the values in our computational formula. Okay, so -4 squared, that is 16, 0 squared, 0, 1.5 squared, 2.25, 1 squared, that is 1, 1.5 squared is 2.25, 0 squared is 0. Now, We must substitute values for n and the summation of all square differences into the formula. So we can also denote the Spearman rank relation as R sub S. From the previous slide, I denoted it as rho, no? We can also do this, R sub S. And this is just equal to 1 minus 6 multiplied to the summation of all square differences divided by n times n squared minus 1. And this is to find Spearman's rank relation coefficient. Here we know that the value of n is 6 since there are 6 data pairs, and the value of the summation of all square differences is 16 plus 0 plus 2.25 plus 1 plus 2.25 plus 0, that is 21.5. Okay, let's go back to the table. We have a total number of 6 observations. Okay, 1, 2, 3, 4, 5, 6. That's why we have 6 here for our n. Okay. Therefore, the value of Spearman's rank relation coefficient is shown below. This is using the formula. No? 6 times the summation of all square differences, that is 21.5, over 6, which is our n, times 6 squared minus 1. Okay, we have 0.385714. So let's interpret that one. So we can correct to 3 decimal places. So it really depends on your liking. Usually we only have 2 decimal places, no? But in this case, let's have 3 decimal places lang. The value of the coefficient is 0.386. Okay, and this is far from 1, so we can say that the ranks are not in strong agreement. Okay. Thus, we can conclude that higher values of variable x do not tend to be associated with the higher values of the variable y, and vice versa. Again, because we have a small Spearman rank relation coefficient, that is 0.3. If we go back to the strength of correlation table, let's go back to the previous slide. Here, 0.39, 0.39. So we have a positively weak correlation. No, if we base our interpretation to this table of to the strength of correlation table, okay, weak correlation, positively weak correlation. Let's go back to the example. Okay, I hope that you know, you now have the idea on how to manually compute the Spearman rank correlation. I know that based on the description of our webinar, you only have to use the Excel and Jamovie software to compute for the coefficients. But it is also helpful if I can show you the manual computation of these coefficients. Okay, so let's have the second example. This is still under Spearman's rank correlation. Okay, later on we also have to show you some examples under the Campbell style. This is still from Nagua. Okay, so credits to Nagua. For the second example, in a study of the relation between students' grades in mathematics and science, the following results were found for 6 students. If you can notice, we now have letters, okay? Since we are considering Likert scale data. So let's say for mathematics, we have these grades, okay? Grade D, grade B, grade A, grade B, grade D, grade D. And for the science subject, we also have these following grades. Now, again, doing the same procedure. First, we have to assign ranks to the mathematics grades. Mathematics muna. Putting the grades in order from highest to lowest gives us, we have rank 1 for A, rank 2 for B, rank 3 for the other B, rank 4 for the first D, rank 5 for the second D, and rank 6 for the third D. If you can notice, we have tied ranks here. So it's very important for us to re-rank our grades, okay? So since we have 2 tied ranks for grade B, we have to take the mean of the 2 ranks. So rank 2 plus rank 3, that is 5, divided by 2, that is 2.5. And for the grades D, this is still under mathematics subject. We have 4 tied ranks, no? Rank 4, rank 5, rank 6. So you have to take the mean of these ranks. 4 plus 5 plus 6 divided by 3, that is 15 divided by 3, that is 5. Now we have our updated ranking. For rank 1, we still have grade A. Okay. Now for rank 2.5, we have 2. We have grades B and the other B. Okay. And for the 3Ds, we have assigned rank 5 to the 3 of them. Okay, we have updated our ranking now. Now let's assign ranks also to the science grades. Okay, so that was for the mathematics grade only. For the science grade, we also do the same procedure. We have to rank the grades A, B, and then if you can notice, we have 3 C's here. And then for the last rank, we have F. So again, since we have 3 tied ranks, we have to take the mean of these 3 ranks. 3 plus 4 is 5. That is 3. That is 12 divided by 3. That will give us a 4. Now for the updated ranking, our A is still in rank 1, our B is still in rank 2, but our 3 C's now are in rank 4. Okay, we have 3 rank 4s now for the 3 C's. Okay, we have updated our ranking now. Okay, let's proceed to the table. The same with example 1. For mathematics, if you can recall, we have these updated rankings. Now, for rank 1, we have grade A. For rank 2.5, we have grade B. And for rank 5, we have grade D. And for the Y values, not the Y values, they should be mathematics, no? Mathematics subject and science subject, not X and Y. Okay. Now, since we have updated our ranking now, we can compute now for the differences between the ranks. No, let's say for example for the first grade under the mathematics subject, we have grade D, and for the first grade under the science subject, we have grade C, and for grade D we have rank 5, and for grade C under science subject we have rank 4. Now taking the difference between the 2 ranks, we have 1. Then you do that to the rest of the grades. Okay. For grade B, we have 2.5 rank. Grade C under science subject, we have 4 ranks. So 2.5 minus 4, that is negative 1.5. And then you do that to the rest of the rankings. I have summarized the different differences here below. We have 1, negative 1.5, negative 1, 1.5, 1, and negative 1. But before we proceed to the computational part of the Spearman rank relation, still have to square these differences. Okay, let's say the square of 1 is 1, the square of negative 1.5 is 2.25, and so on. Now, since we have values for our square differences, we can substitute these values to the formula now. Okay, to find Spearman's rank relation coefficient, the same procedure. The same procedure that we did from example 1. We must substitute values for n. Our n here is 1, 2, 3, 4, 5, 6. We still have n equals to 6. N is the number of observations. Okay, n equals to 6. And then the sum of all the square differences, 1 plus 2.25 plus 1 plus 2.25 plus 1 plus 1, that is 8.5. Okay. Now the value of our n, which is 6 because we have 6 observations, and the value of the sum of all these square differences is 8.5. Since we have now these values, we can now substitute these values to the computational formula of our Spearman rank relation. Okay, substituting the values, we have come up with 0.7571 for the interpretation. Let's say we correct to 3 decimal places. The value of the coefficient is 0.757. This is close to 1. So we can say that the ranks are in fairly strong agreement. Thus, we can conclude that students with high grades in math also tend to have high grades in science and vice versa. Okay. So those are the 2 examples under the Spearman rank correlation. If you have any questions, you can write that down and then you can raise that when I finish my lecture. Okay. Before we proceed to the use of the Excel and Jamovi software, let me introduce first the Kendall style. Okay, before that, we can also use hypothesis testing. Okay, when we consider Spearman's rank correlation as a test statistic for our, let's say, research. Recall your elementary statistics. We have the following steps when we conduct hypothesis testing. For step 1, you have to state your null hypothesis and your alternative hypothesis. For step 2, you have to set the level of significance alpha. It's more common to use 0.05 as our level of significance. Now, for step 3, determine the critical value. Okay, in this case, we use T for the test from the Spearman rank critical value table. For those who are not familiar with the Spearman rank critical value table, you can always search that on Google. Okay, we have that available on Google. For step 4, you compute for the test statistic. Okay, we have here the formula for our test statistic. First, we have to compute for the coefficients of our Spearman rank correlation. Okay, that is very important for us to get the value of our T. Okay, our R here is the sample correlation coefficient between X and Y. The statistic T is also distributed as a student's T with n minus 2 degrees of freedom. For step 5, we make our decision. That is either to reject or not to reject our null hypothesis. Okay, and we have this decision rule. We reject our null hypothesis if the absolute value of our T, which is our test statistic, is greater than the value of our critical T. Okay, the value of this critical T can be found in the Spearman rank critical value table. And then for the last step for the hypothesis testing, state the conclusion. Okay, this is very important for the students, especially in the social science field or in education, because I know most of the time your advisors or panelists will require you to have or to conduct a hypothesis testing in your research, especially in your thesis writing. So this is very useful, especially if you are considering as early as now in using a Likert scale survey questionnaire. So this is one way of testing the hypothesis of your research. Okay, you have to remember this one. So let's have this example for the hypothesis testing. Suppose a researcher wished to test the claim that exercising is beneficial not only physically, but also psychologically. They hypothesized that exercising improves self-esteem. They sampled 10 female fitness gym members and have them fill out a survey involving scales. The first variable measures involvement in physical exercises and the other measuring self-esteem. Now we have to test the hypothesis that the involvement in physical exercises and level of self-esteem are significantly correlated at 5% level of significance. I just want to credit the writer of our Stat 101 module. I think Professor Aboy is one of the authors. No, this is a snippet, or this is from the Stat 101 module that we are using in our classes in Stat 101. Okay, now the scores presented are as follows. Okay, we have here, let's say names of the gym members. No, we have Lisa, Monica, Fabi, up to Emma. And we have here for the first variable, we label it as the X variable. This is for the involvement in jogging. And for the second variable, we denote it by Y. We have here for the self-esteem. And we have the following ratings. No? Okay. Now, the Spearman rank correlation coefficient between the two variables is determined by the formula. Okay. This is the third time that we have encountered this formula, no? From the history of the Spearman correlation coefficient, from the two examples that we had, and then here, we still have this formula, and it is denoted by R sub S, or we can also denote it by rho, but it's safer to use R sub S now because we denote the Pearson's R as rho. So R sub S na lang. Okay, so we still have this formula, very familiar. Now for the table, the same thing that we did from the first two examples that we had. We have to rank, okay? We have to rank the different ratings. And if we have tied ranks, we have to re-rank those ranks. Okay, for example, we have 2 8s here. Since we have 2 8s for rank 7 and rank 8, so we take the mean of these ranks, 7 plus 8 divided by 2, that is 7.5. That's why we have here the updated ranking. That is for variable X. Now for variable Y, unfortunately, we have no tied ranks, no? So we do not have to re-rank the ranking. The next step that we have to do is to take the differences between these ranks, okay? 1 minus 3 is negative 2, 2 minus 1 is 1, 3 minus 4 is negative 1, and so on. And then we take the squared. We take the square of these differences, okay? Negative 2 squared, that is 4, and so on. And then we take the sum of all the squared differences because we're going to use this when we compute for our Spearman rank correlation coefficient later on. Okay, we have some note here. This is for the tied rank. Now, the sample Spearman rank correlation for the n equals to 10 observation is we have here. Based on the previous table, the value for the sum of all square differences is 22.5, okay? And the number of observations involved in the survey is 10. That's why we have n equals to 10. And for the sum of all square differences, we have 22.5 that we have computed a while ago. So following the formula, we have come up with this correlation coefficient, 0.8636363364. Okay, therefore, there is strong positive relationship between the variables. Okay, excuse me. It's closer to 1 man. And respondents who are highly involved in physical exercises also ranked high on self-esteem level. Okay, so there's a positive correlation or association between the two variables X and Y. Now, we have to test the hypothesis. And this is now the different steps on how to conduct our hypothesis testing. First, we have to indicate our hypothesis. We have the null hypothesis and the alternative hypothesis. For the null hypothesis, we have there is no significant rank correlation between involvement in physical exercise and self-esteem level. For the alternative hypothesis, we have here there is a significant rank correlation between involvement in physical exercise and self-esteem level. So our goal here is to reject our null hypothesis, okay? So that we can accept the null, that there is a significant rank correlation between the two variables, okay? And on how to reject our null hypothesis, we have to make sure or we hope that our, let's say, the value of our test statistic is greater than the value of our critical value, okay? That is based on the rank correlation table. Now, at 5% level of significance, the critical values for the Spearman rank critical value table are, this is based on the table. If you are not familiar with the table, I can flash the table here in the right side of my presentation. So this is the upper critical values of Spearman's rank correlation coefficient. If you can notice, our alpha is 0.5, no, 0.05. And then we divide it by 2, we have 0.025, okay? And that is, and we can observe the different level of significance in the column headings of our table. Now, since we have n equals to 10, that is the total number of observations in our survey, we, since we're considering n minus 2 degrees of freedom, we have to deduct 2 to that, let's say, total number of observation. That's 10 minus 2 is 8. We have here in the first column, the different observation of number of observations. We have 8 here, and then we have 0.025. And based on the table, we have come up with this probability 0.738. Okay, that is the Spearman rank correlation table. You can Google it if you want to. Now, given that the computed R sub S, which is our Spearman rank correlation coefficient, that is 0.863 or 864, the test statistic is this one. Okay, I told you a while ago that first we have to compute for the Spearman rank correlation coefficient in order to derive our test statistic, no? Because the value of our Spearman rank correlation coefficient will be in the numerator of our formula. And using the formula, we have come up with 4.85. This is now our test statistic. Now, since the test statistic, which is the absolute value of our t, 4.85 is 4.85, and this is larger than the critical value that is 0.738, it follows from the decision rule that we reject the null hypothesis at 5% level of significance. Now, to conclude, therefore, there is a statistically significant rank correlation between physical exercises involvement and level of self-esteem. Let's go back to the steps, for you to be reminded of the steps. We have here, for our decision rule, we reject the null hypothesis if the absolute value of our test statistic is greater than to the critical value based on the Spearman rank critical value table. Okay, you have to remember this one. And we have concluded that there is a positive correlation or association between the physical exercises, involvement, and the level of self-esteem. I think that most of you will agree to this, no? There really is a positive correlation between the two variables. Okay, that's it for the Spearman rank correlation coefficient using manual computation. Let's proceed to the Kendall's rank correlation. Okay, again, we use the Kendall rank correlation if we have a small sample size and we have many tied ranks. Okay, so let's have a brief discussion about the Kendall rank correlation. Kendall rank correlation is a non-parametric test that measures the strength of dependence between two variables. Again, non-parametric test. So in this test, we are not assuming normality with our variable. We also do not assume homogeneity and inequality of, let's say, sample sizes. Okay, that is for Kendall rank. We have key terms here. We have the concordant and the discordant. If you can remember from the computational formula, we have n sub c and n sub d, right? So we have concordant and discordant. So concordant, the ordered in the same way. Okay, for discordant, ordered differently. So later on, I will show you I think, 2 examples under the Kindle rank correlation, manual computation, for you to really understand the concept behind this statistical test. Okay, let's have this first example from Stephanie Glenn. So credits to Stephanie Glenn for this example. We have here the sample question. 2 interviewers ranked 12 candidates A through L for a position. The results from most preferred to least preferred are, let's say for interviewer 1, we have A, B, C, D, E, F, G, H, I, J, K, L. Okay, this is the ranking of interviewer 1. Now for interviewer 2, he or she has a different ranking, no? A, B, C, A, B, D, C, F, E, H, G, J, I, L, K. Okay, different ranking. Now, for this example, we have to calculate for the Kendall-Tau correlation. For the answer, we have to follow some steps. For step 1, we have to make a table of rankings. Now, the first column, we have the candidates, A to L, okay? A through L. And this is optional and for reference only, okay? But it's more parang advantageous din, no? Pag we indicate the different candidates, okay? For reference lang. Okay, the rankings for interviewer 1 should be in ascending order from least to greatest. So we have to make sure that for the first interviewer, in this case, we are considering 2 interviewers, man. We have to make sure that the ranking of the first interviewer is in ascending order, okay? Tapos for the second interviewer, the ranking will adjust na to the first interviewer, okay? That is first step. You have to remember that one. Now for step 2, we have to count the number of concordant pairs. Using the second column, concordant pairs are how many larger ranks are below a certain rank. For example, the first rank in the second interviewer's column is A1. So all 11 ranks below it are larger. Okay? Okay. Based on this table, all ranks below 1 are greater than 1. It means that all of these ranks are concordant to the first candidate. Now we have 2, 4, 3, and so on. So if you count the number of ranks, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 total numbers of ranks. So this is now the first concordant. Okay. Again, you have to bear in mind that we only count the ranks that are larger than the, let's say, this rank right here. Okay. Or the corresponding rank that we are focusing on. Okay, let's proceed to the, let's complete the concordant. For example, if we consider the second candidate, that is candidate B, if you can notice, 4 is greater than 2. So we count that as 1 concordant, okay? But here, since this 3, no. Okay, let's focus muna sa this rank here, rank 2, okay? So all of the ranks under 2 are greater than 2. We have 4, 3, this is 3. 4, 3, 6, 5, 8, 7, up to 11, okay? So all of these ranks are greater than 2, meaning we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 concordants, okay? 10. Now, considering the fourth, or let's say the third candidate, for interviewer 2, candidate C was ranked number 4. So we have to count all the ranks that are greater than 4, okay? Below 4. So this is 3. Hindi masyadong makita, na? Hindi masyadong nakikita. We have 3 here. 4 is not less than 3. Okay, 3 is greater than 4. That's why we cannot count this as a concordant. So we have to start counting from 6. so on. 6 is greater than 4, 5 is greater than 4, 8 is greater than 4, 7 is greater than 4, up to 11. 3 is not greater than 4. That's why we cannot count that as a concordant. Therefore, for the third candidate, that is candidate C, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers, 8 total number of concordants. Okay, I hope that that's clear to you. We do not count we only count the greater the ranks that are greater than this rank right here that we are focusing on. Okay, since 3 is not greater than 4, we know that, especially in our basic counting, no, basic fundamental principle of counting. 3 is not greater than 4, so we cannot count that as a concordance. So we have only 8 here. Okay, let's complete our concordant. Now for 3, of course, 6, 5, 8 up to 11 are greater than 3. So we count all of these ranks as a concordant of 3. We have 8. For 6, now 5 is not greater than 6. Okay, 5 is not greater than 6. So we cannot count this as a concordant to our candidate here. Okay, so we only have 1, 2, 3, 4, 5, 6. That's why we only have 6 concordant for this particular candidate here. Okay, under interviewer 2, and so on. I hope that's clear to you. Now let's have step 3. We have to count the number of discordant pairs and insert them into the next column. The number of discordant pairs is similar to step 2, only you're looking for smaller ranks, not larger ones. Okay, for concordant, we are looking for the larger ranks. For discordant, we are looking for the smaller ranks. So let's have here 11. So if you can notice, we have no ranks below 11 that are smaller than 11. So we have 0 discordant. Let's not base our discordant here in the concordant column. Let's base our discordant here in the interviewer 2 column. Okay, smaller. Okay, if we focus on this candidate, if you can notice, there are no ranks that are lesser than 1. That's why we have 0 discordant. Okay, here in number 2, we do not have ranks that are lesser than 2. Therefore, we have 0 discordant. Now for 4, 3 is clearly less than 4. That's why we have 1 discordant here. Okay, and then for 3, we have no ranks that are lesser than 3. Under 3, that's why we have 0 concordant. And we do that to the rest of the cells. Okay, we now have our concordant and our discordant. I hope that's clear to you. For the fourth step, let's sum the values in the 2 columns. Okay, we sum the total number of concordant and the total number of discordant. So for the concordant, we have a total number of 61, and for discordant, we have a total number of 5. Okay, for step 5, let's now insert the totals into the formula. We have the following formula for our Kendall's Tau. This is the number of concordant minus the number of discordant divided by the number of concordant plus the number of discordant. And that is 61 minus 5 divided by 61 plus 5. 56 divided by 66 is 0.85. Now the tau coefficient is 0.85, suggesting a strong relationship between the rankings. Okay, gets Kendall's Tau. The crucial part in computing the Kendall's Tau manually is the getting your concordant and discordant. No, this is very important to understand before proceeding to manually compute for your Kendall's Tau correlation coefficient. So let's have here some statistical significance when we consider Kendall's Tau correlation in our research. If you want to calculate statistical significance for your result, this is still from Stephanie Glenn. Okay, use this formula to get a z-value. So we have the following formula for the z-value. We have 3 multiplied to the value of our Kendall Tau multiplied to the square root of n times n minus 1. And here is the total number of observations divided by the square root of 2 times 2n plus 5. Now, inserting the values from our results, we have 0.85 as our Kendall tau here, okay? And you still remember 0.85. And then we have 12 total number of observations. Let's go back. We have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, n equals to 12. By substituting these values, the value of our n and Kendall tau, we have come up with a z value 3.85. Now, finding the area of a z-score of 3.85 on a z-table gives us an area of 0.0001. And this is a tiny probability value which tells you this result is statistically significant. Again, for the z-table, you can always find that on Google. Okay, this is one way in calculating your statistical significance when you are considering Kendall-Tau correlation coefficient in your research. I hope that you have learned the different, let's say, concepts that you can apply, okay, using Kendall-Tau correlation. We can manually compute the coefficient. You can also calculate the statistical significance, okay? Let's have the second example, okay? Second example, for you to really understand the concept of Kendall-Tau. Again, you have to keep in mind that we are considering ordinal scale data in this case, okay, for Kendall-Tau. For example, number 2, suppose 2 basketball coaches rank 12 of their players from worst to best. The following table shows the rankings that each coach assigned to the players. We have players AJ, Ben, Connor, up to Luke. Okay, for coach number 1, again for coach number 1, he ranked AJ first. Okay, he ranked Ben second, and so on. For coach number 2, he has a different ranking. Okay, so coaches 1 and 2 have different rankings when it comes to their players. For the answer, let's have, again, step 1. Count the number of concordant pairs. Before that, you have to make sure that you, let's say, you list down all the rankings from coach number 1 in an ascending order. Okay, it's very important that you arrange your ranking in ascending order for the first coach, and then the second coach will let's say follow. Okay, now the first step is to again compute for the concordant. If you can recall, concordant are the number of ranks that are greater than the rank that we are focusing. Okay, in this case, we're focusing on AJ. For coach number 2, AJ is ranked number 1, and all the rankings below AJ are greater than his ranking. That's why we consider all these rankings 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have a total number of 11 concordants. Okay. Now for Ben, if you can notice, all the rankings below Ben are greater than Ben's rank, which is rank 2. Okay. Therefore, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 number of concordants. Okay. And we do the same procedure to the rest of the cells. Okay. We have 11, 10, 9, 7 to 1. Okay. Now let's proceed to the computation of the discordant. Again, the difference between the two. For the concordant, we are considering the rankings below the specific rank that we are focusing on. We have to count the greater, the ranks that are greater than this specific rank. For discordant, we count all the ranks that are lesser, okay, or smaller than the rank of this specific, let's say, player, which is AJ. No? For discordant, if you can notice, all the ranks below the rank of AJ here, let's focus on the third column. All the ranks below the rank of AJ are not less than his rank, okay? Therefore, we have 0 discordant. For example, for Ben, all the ranks below Ben are not lesser than the rank of Ben. Therefore, still have 0 discordant, okay? And we do that to the rest of the cells. If you can notice, we have 1 discordant here for Dwayne. Now, Dwayne's rank is rank 5. And if you can notice, Elliot's rank is 4. So Elliot's rank is lesser than the rank of Dwayne, no? So we have 1 concordant in this case, okay? And the rest are 0 and 1. That is the same procedure that we did from the last example. Okay, I hope that you can still remember. Now, for step 3, we calculate the sum of each column and find Kendall's tau. First, we have to take the sum of all the concordants and then the sum of all the discordants. After getting the sum, we can now get our Kendall's tau coefficient using the following formula. We have the number of concordant minus the number of discordant divided by the number of concordant plus the number of discordant, and that is 63 minus 3 divided by 63 plus 3, 60 divided by 66, that is 0.909. We now have our Kendall's tau correlation coefficient. It's closer to 1, no? You can say that there is a positively strong correlation between the rankings of the 2 coaches. Okay. Okay, are we okay now with the interpretation of the Kendall's tau coefficient? There is a positive correlation between the 2 rankings of the 2 coaches. Okay. It means that, for example, if AJ is ranked higher by coach number 1, then coach number 2 will likely rank AJ also in a higher rank. Okay, positive correlation or positive association. You can also have here statistical significance of Kendall's tau. The same procedure that we had from the first example. When you have more than n, let's say 10 pairs, Kendall's tau generally follows a normal distribution. You can use the following formula to calculate a z-score for Kendall's tau. Okay. Okay, our tau here again is the value that we have calculated a while ago. That is 0.909, right? And our n here is the number of pairs. We have 10. So by substituting these values to the z formula, we have 4.11. Okay. Now using the z-score to p-value calculator, because if you can notice 4.11, for our z table, we only have from -3 to 3, no? But in order to get the probability of the specific z-score, we can use some statistical software like R. Okay, we can use R. But in this case, Zach, which is the author of this example, used the z-score to p-value calculator. But again, you can still use the R software. We see that the p-value for this z-score is 0.00004, which is statistically significant at alpha level of 0.05. Therefore, to conclude, there is a statistically significant correlation between the ranks that the 2 coaches assigned to the players. Okay, I hope that you understood the 2 examples. Let's now proceed to the use of Excel and Jamovie. Okay, 249. Okay, this is the most important part of this webinar, to use the Excel and Jamovie software, or to use Excel and Jamovie software in conducting, let's say, Kendall's tau and Spearman rank correlation coefficient. Let's Spearman rank correlation. Okay, let's have our Excel Where is But before that, I would like to share to you on how to get the reliability test. Okay. I think last webinar, most of you were asking about asking on how to wait lang ha, reliability test exam. This one. Share my screen. Okay, Miss Jera, can I share my another, let's say, window? Can I stop sharing my
Yes, sir.
presentation now?
Let's ask Noel for the controls. Noel,
Miss Noel, can I?
Sir Joseph would like to share
Yes, sir.
his
Stop
other
share
window.
lang, sir, sa ikuhang ano, and
Stop
then
share.
open again.
Okay, thank you. Stop share, and then I want to share my Excel. This one.
Yes, sir.
I hope that my Excel is now visible.
Yes, sir.
Yes,
It's
sir.
visible.
Okay. For those who were asking, when will the Likert data be used? Because somebody actually asked kanina, because Sir was not using Likert data in showing some of the basics on how to compute. So this is the time when we will be using the Likert data. So this is Sir Joseph's demonstration in which he is using Likert data and survey data.
Okay. So I just want to clarify, based on my previous examples, for the Spearman rank correlation, for the first example, I used one ordinal data and then the other one is quantitative. And based on the table that I showed, that I showed you from the previous slides, we can use Spearman correlation coefficient in getting our, let's say, association between the two variables. If we have one ordinal data and one interval or ratio scale data. So the first example under the Spearman rank correlation is still under the Likert data analysis. Okay, and then for the second example, if you can notice, we have their A, B, C to F grades. Okay, those grades are in ordinal scale. Okay, so those variables are ordinal scales. Okay, so we can, that is still under the Likert data analysis. That is the main purpose of this webinar. And for the Kendall's Dow, I also use ranking. For example, the different rankings of the two coaches. Okay, coach number one ranked the players. Coach number two ranked the players. Those rankings are in ordinal scale. And then for the first example, for the Kendall Tao, that was the ranking of the different ratings of, let's say, the participants are the ones who are doing gym exercises, and the other variable are the ones who are assessing their self-esteem. Okay, the questionnaire that were employed to them are in Likert scale. Okay, rating 1 to, let's say, 5. Okay, rating scale. So those examples are still under the Likert data analysis. Is it clear na that based on the data that I used to my 4 examples, those data are still under the Likert data analysis? Everyone?
Okay, I think they already got it. Thank you
Yeah.
so much, sir.
Thank you, sir. Thank you, Ma'am Jara. Okay, let's proceed to the reliability test. I know that it's very controversial to use Conbox Alpha, especially in the terminologies, and the two terminologies, reliability and validity. In this case, let's get the reliability of our questionnaire. Okay, so we can execute this one using Excel, and we can also show this using Jamovie. So let's take, for example, I have here a survey, Likert scale survey questionnaire, and the study is about the the different problems that tourists are experiencing in visiting Tinago Falls in Iligan City. So this is an existing study, okay? I just borrowed their survey questionnaire. So this is actually from my students, and they allowed me to use their survey questionnaires, okay? We have here the different variables for demographics. We have the gender, the age bracket, the civil status, occupation, highest educational attainment, and so on. And we have the following questions, and it's a bit small now. For the first question, we have, my wage in Tinago Falls is fair enough to sustain my everyday needs and necessities. So we have 1 to 5 scales, okay? That is agree, strongly agree, neutral, okay? So we have here, let's say, a hypothetical response, okay, from the respondents. So in order to compute for your Cronbach's alpha, we have here the manual computation of the Cronbach's alpha. I made this table, so I can freely use this. We have table, let's say, you can label your table any way you want. I labeled my table 1.3 because I have here 3 survey questionnaires. But let's focus muna sa employee na respondents. We have here table 1.3, reliability testing for employees instruments. Okay, for the first column, you have the variables. The second column, you have the description. The third column, you have the values. And the fourth column is the decision to whether accept or not accept the reliability of the questionnaire. So we have here the computational formula for our Cronbach's alpha. This is just the product between k over k minus 1 and 1 minus the summation of all squared item variances over the square of all the scores. No. The total variances. Okay, we have this computational formula, and I am showing you on how to execute this formula manually. So let's say, for example, the number of items is 13. We can validate this one using some count function in Excel. But I can assure you that we have a total number of 13 items here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. And then let's say the sum of the item variance is 2.08. The variance of the totals is 7.84. And we have come up with the Cronbach's alpha of 0.79. Okay. Also another information, we accept our or we can say that our survey questionnaire, or in this case our instrument, is acceptable if our Cronbach's alpha is greater than 7.0. But there are researchers who are suggesting that 0.6 is acceptable. Okay, it really depends now on your study. Okay, but in this case, let's stick with 0.7, which is the threshold in accepting your reliability. Okay, so this is the manual computation of the Cronbach's alpha. If you have the values for your, let's say, number of items, the sum of the item variances, the variance of the total scores, and these 3 components. Okay, but in using Excel, the first thing that we have to do is to get the variance of each item. Okay, we can use the function var.p in Excel. Okay, we have here the function var.p, and then we indicate the number of cells. So supposedly we have come up with a variance of 0.16 for the first item. Then you can drag your, say, function or formula to get the other variances. Okay, let's say for item 1, we have 0.16, item 2, 0.16. If you can notice, there's an equal variances between each items. No? So this is just a hypothetical response. For the next step, you have to compute for the variance of total scores. So the first thing that you have to do is to to get the sum of all the responses from item 1 to item 13. Okay, we can take the sum of these items. And we have 51, 51, we also have 44, and 44 for the last respondents. This is respondent number 1, respondent number 2, respondent number 3, and so on. Okay, after getting the sum of all the let's say responses from each respondent, we now take the variance of the total score. Okay, the variance of the total score. If you can notice, we still use the var.p function in Excel, and then our cells now are AA2 up to AA11. Okay, because these are the total number of scores from each respondent. Okay. Now that we have these components, the number of items, that is 13, the sum of item variances, and the variance of the total scores, we can now compute for our convex alpha, okay, using this formula. This formula is derived from the manual formula, or let's say computational formula of the convex alpha, okay? That is K, our K here is in the N16 cell, that is 13, and then K minus 1, 13 minus 1, multiplied by 1 minus, this one is the sum of the item variance, and the denominator is the variance of the total score. So we get a 0.795918367 reliability coefficient. This is the same with the convex alpha, or the reliability coefficient that we have computed manually. Okay, we can notice. Now let's show if we can come up with the same reliability coefficient using Jamovie. Even, you can raise your questions later on if you have clarifications about the reliability test using Excel software. Okay, let's proceed to the use of Jamovie. So in using Jamovie, let me unshare my screen, and then let me share my Jamovie screen. Okay, Jamovie loading pa. Okay, I hope that everyone can see my screen now. Jamovie. Here we get our data. Say we have a data here. Reliability test, Jamovie. So this is the same data. Okay, let me share my screen again. If you can notice, this is the same data that we used when we computed for our convex alpha. Excuse me. Okay, this is the same data that we used when we computed for our convex alpha using the Excel software. So we want to confirm if Excel and Jamovie will, let's say, compute for the same value for our convex alpha. Okay, using the Jamovie software, let's proceed to the factor. Under the factor, we have the reliability analysis. Okay, you click that, and then you include all the items in your survey questionnaire. Okay, include all the items. There's a total of 13 items, if you can still remember. Okay, Jamovie is still loading. Okay, you can notice the value of our convex alpha is 0.796. Okay, and that is the same with the convex alpha that we have calculated using our Excel. Okay, let me share the Excel file, me share my Excel for your reference. Okay. Remember, we have here the computed value or let's say coefficient of our convex alpha using the Excel. This is 0.79 now, and this is the same with the convex alpha coefficient that we have calculated or computed using the Jamovie, 0.796. Okay, I hope that you can now do this by your own. This is very easy now to use in Jamovie. You just have to put the items in our let's say window here, the second window, and then it will give you your convex alpha coefficient. And also Jamovie will give you some notes. For example, items tourists purchase any of the local products in Tinago Falls. This is one item, no? The knowledge being instilled from the training or seminar are applicable in the situation of Tinago Falls. This is also another item. And the third item is the training and seminars I had are enough to reach a satisfactory level of service. And these three items correlate negatively with the total scale and and probably should be reversed. So Jamovie can actually detect if you have negative, let's say, correlation between items. So it's very helpful for us researchers. Now we can also click this one, convex alpha, if item is dropped. Okay. Okay, let's have this one. So here for the first item, just remember that these are items, item 1, item 2, item 3, up to item 13. For the first item, if we drop this item, then we still have a convex alpha 0.727 that is greater than the threshold that we set, that is 0.7. It means that we can still say that our instrument, in this case, the survey questionnaire, is reliable. Okay. Now, if we drop the second item, we still have a convex alpha coefficient greater than 0.7. Okay, we still can say that our questionnaire is reliable. Okay, this is very helpful if you want to do some, let's say, backward selection of your items, no, to really understand which item is affecting your reliability. So you can do that in Jamovie. Okay. That is for the Excel and for the Jamovie. You can write your questions if you have any, so that you can raise those questions during the Q&A portion. Okay, this is just one way of showing you on how to do reliability analysis using Jamovie, because I think last webinar, last Wednesday, may not question ito, no? And we were not able to show you yet the proper way on how to do reliability analysis in Excel and Jamovie. Okay. Enough of the reliability analysis. For sharing. Let me share my screen now for Spearman. Wait lang ha. Spearman and Campbell. Okay. Spearman and Campbell. Give me one second. Okay. Now for the Spearman and Kendall-Stowe analysis, let's use the same questionnaire. Okay, for simplicity. Let's say we have here the employees, right? Employees, median response. And then for the second variable, we have the educational attainment. For the employees median response, we can use the median function in Excel. And then for the cells, we choose from cell N2 up to Z2. Okay. Then we just drag that down to get the other medians. Okay. For the educational attainment, let's get this information that we have here from our survey questionnaire, and just copy that. Then we now have our second variable. Okay. Now, for Spearman correlation, we actually have a function in Excel that is ready to compute for the Spearman correlation. We have the correl. Okay. Wait lang. Let's rank muna, and then because I'm not going to show you the function only, but also the manual computation using Excel. Okay. Let's start with the manual computation. Okay, using Excel. So if we do the ranking for the employees median response, 4 is rank 1, the other 4 is rank 2, and then we have the remaining ranks. Okay, rank 1 to rank 10. If you want to re-rank these rankings, because we have tied ranks, right? For the 4, 2 plus 3, that is 2 plus 1, that is 3 divided by 2. This 1.5, right? Okay, can you recall from our first example on how to re-rank our rankings if we have tied ranks? We have the updated rankings. Now, for the remaining ranks, we have tied ranks still. No, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 tied ranks. So we have to, let's say, you have to get the sum, okay, of these ranks. You can use that using this formula, and then we divide it by 8. Okay, divided by 8. So we have 6.5, which is the updated ranking of our, let's say, this specific respondent right here. So we just copy that one to the rest of the, we can copy this as value, okay? Now we have updated our ranking, okay? So these are now the updated rankings. Let's also re-rank our educational attainment. Let's say our rank 1 is for the high school undergraduate. Okay, rank 2 is for high school graduate. Rank 3 is for college undergraduate. No? College undergraduate. Unfortunately, we only have 3 levels of educational attainment here based on our hypothetical Likert scale, Likert questionnaire. No? So in some cases, we have additional educational attainment, but in this case, you only have 3 ranks: the high school undergrad, high school graduate, college undergrad. Okay. Now let's assign some ranks to this educational attainment. For rank 1, we have high school undergraduate. So we rank this as 1, high school undergraduate. 2, let's say 1, okay? High school undergraduate, 1, 1, 1, 1. And then for the high school graduate, we rank this number 2, high school graduate, 2, 2, okay? 2. And then for the last one, the college undergraduate, you rank that educational attainment to rank 3, okay? Again, we have to re-rank these rankings because we have tied ranks, right? For the first tied ranks, we have 1, 2, 3, 4, 5, 6. Okay. No. We still have to rank them. So we have here the first rank, the second rank, third, fourth, fifth, sixth. Okay. And then this is the 7th rank, and the 8th. No. This is the 8th one, and then the 9th rank, and then the last one is the 10th rank. So these are the ranking of our educational attainment variable. In this last portion, we have to re-rank because we have tied ranks, right? We have tied ranks for rank number 1, 2, the rest of them. Okay, so we have to add their rankings. That is 1 plus 2 plus 3 plus 4 plus 5 plus 6. Divided by how many? 1, 2, 3, 4, 5, 6. No? We have 3.5. So we paste that as value to the rest of the variables with the same ranks. Okay, 3.5, 3.5. Now for the let's say high school grad, we have 3 tied ranks, right? So we have to again add these rankings 7, 8, and 9. Okay, divided by 3, that is 8. So copy that as value. Let's give them a color of, let's say, blue. Pwede masyadong confusing. Okay, so this is, it should be red in color. And it should be blue in color. And then for the last rank, it still has the rank 10. No? Now we have our updated ranking. So to compute for the Spearman's rank correlation, we just have to use the formula. Okay, equals for rel, and then we specify the updated rankings. So for the first array, we have this one. Then you put comma, and for the second array, we have this one. Then you close the parenthesis. We have 0.3984. Okay, this is now our Spearman's rank correlation. Now, what if we use the manual computation? Okay, for the manual computation, we have the formula. Let me check the formula. Windows rank. So 1 minus So we have here the formula. So let's rewrite the formula using the Excel formula. We have 1 minus minus 6 times the sum of all. Okay. Before we can do that, we still have to get the differences. Okay. Get the differences between the ranks. So let's have here d and then d squared. For d, we just have to get the difference between this rank here and then the second rank for the second variable. Okay, and then you just drag that down to get all the different differences. And then we can square these differences, no? Okay, we now have our square differences. And to take the sum, we just use the sum function in Excel. Then you can now have the sum, okay? Sum of the squares. It's very important. Okay, also n is 10, right? N is the total number of observations. Now, if we want to replicate this formula, we can use we can use the Excel, right, to write our own formula. 1 minus 6 times 6 multiplied by the sum of all the i's, okay, and then divided by the total number of n times the square of this n minus 1. Let me check if there won't be an error at this function. 1 minus 3 n times n squared minus 1. Wait lang ha. Times 1 minus 6 divided by, okay, times, nope, not that one. Oh, nope. Give me some time to rewrite the formula, okay? 1 minus 6 times the total number of the square differences. Okay. Divided by n, which is 10, and then the square of that n minus 1. Let me write this one. This is not the one. Okay, wait lang. Give me some time muna to rewrite the code, okay? Okay, this one. Okay, let's go back. No, no. Okay. So you have this formula. Instead of this one. Okay, that's 10. Okay. We have 0.618 as our Spearman correlation that is not the same with this one. Okay, let me recheck. Okay, this is the sum of D. Our N is 10, 2 minus 1. Okay, let me check the ranking. Coding, 1, 2, 2, undergraduate, high school graduate, undergraduate, graduate. Okay, 1, 2, 3, 4, 5, 6. Okay, 7, 8, 9, 10. Then re-ranking. Okay. Okay. We can double check if what is the correct coefficient for our Spearman's rank correlation. Because in Excel, if we use these re-rankings in the Movie software, okay? Let's try. Not this one. So in doing that, we have to copy these re-ranked values to, let's say, another Excel file. Okay. Let's name this as X and then Y. Then we can save this in our movie as, let's say, Spearman. Now let me go back to the movie. Okay. So that we'll know kung saan yung correct na coefficient within the two. Let me hit this one. So bear with me, guys. I have to open first my movie and then, okay, share my screen. Share movie, share. Now, going back to the movie, we have to load our data, right? So I named our Excel Spearman. Okay, I have to share again my movie. Okay, we have now X and Y. If you can remember, these are the re-rankings of our variables X and Y, right? The first variable is the median response of all respondents. We have total number of 10 respondents from our hypothetical survey questionnaire. And for our second variable, which is the Y variable, this is the educational attainment of the respondents, okay? We want to check the association between the median response of these respondents and their educational attainment. Okay, we can use, let's click regression, correlation matrix, and then Spearman. We have to put our variables into this window, and we can compute for our Spearman value. Now, the value for our Spearman is 0.398. Okay, 0.398. Remember that. Let's go back to the Excel file. Excel file. This one. 0.398, right? 0.398. Okay, so this is the correct one. For the computational formula, I actually was able to rewrite the formula for this now in Excel, but I don't know what happened. I don't know what or where did I get wrong. But you can always do this, right? If you have, for example, an existing formula, you can always transfer that to Excel, okay? But let's stick to the correlation function that Excel can provide us, which is the correl. Okay, but remember that the correl function. So based on the correl function from the Excel software, we have come up with a Spearman correlation coefficient 0.3984095. Okay. Now for our Jamovi, if you can still remember, we also have 0.398 as our Spearman's rho. Okay, so you can see that the Spearman's rank correlation coefficient that the Excel and Jamovi have computed is the same. Okay, the same. We also have the p-value for our Spearman here. This is very important, especially in hypothesis testing. No, so you can say that Jamovi is really a good statistical software for those who are new to statistics. Okay, it's very user-friendly. You can just click on the desired functions that you want to use. Okay, now for Kendall's Tau, you can also get the coefficient for our Kendall's Tau B. If you are from let's say curious about the letters here, we actually have Kendall's Tau A, B, and C. Now, Kendall's Tau A and B are more appropriate if we have a square table. Okay, it means that if the number of the rows or if the number of our rows is equal to the number of columns. Now, if we have a rectangular table, meaning the number of rows is not equal to the number of columns, then we can use the Kendall Tau C. However, in most statistical software, the only built-in statistical test, especially for Kendall's Tau, is the Kendall's Tau B. So in this case, we are using Kendall's Tau B. Okay, and you do the same procedure, the one that we did using the Spearman's rank correlation in getting your Kendall's Tau correlation coefficient. Now, if you're curious about the use of Excel software in getting our Kendall's Tau correlation coefficient, you still have to download and add in. It's called Megastat. So in my case, I tried to download the Megastat add-ins in my map. No. Unfortunately, I wasn't able to do that, so I cannot show you on how to do Kendall's Tau B using Excel software. But I can assure you that there is a function in Excel that can compute for Kendall's Tau correlation coefficient. That is an add-in called the Megastat. Okay, still have to download that add-in. So in this webinar, I can only show you on how to get the Spearman's rank correlation coefficient using Excel and Jamovi, and on how to get the Kendall's Tau correlation coefficient using Jamovi only. Not, I can't show you not to do that in Excel yet because I wasn't able to download the add-ins pa, the Megastat. Okay, what else? So let me go back to the. So I think that's it, no? These are my references, and thank you so much for listening. I'll be happy to answer your questions.
Okay, thank you so much, Sir Joseph. So, bigyan po natin ng short while si Sir Joseph na makapagpahinga. Okay lang po ba? Mga 2 to 3 minutes?
It's
Okay,
okay.
so
I can.
you can also look at the open questions at our Q&A box, and then you may also want to pick some of the questions which you wanted to answer first. Okay, but pahinga ka muna, sir. And then let's say hi to our participants. We have a lot of participants right now. Some are coming from Mindanao, some are coming from Visayas, and of course from NCR. We have some participants from PUP. We also have participants from UP Clark. So if you don't know, we have UP Clark. And also other participants coming from different universities. So also, we would like to invite you or to Okay, so this series actually is a 3-part series. We are already done with our first part, that is Introduction to Likert Data Analysis. And today we have our session with Sir Joseph for the Likert data analysis using different inferential methods. So in this case, Sir Joseph was able to show us or demonstrate to us how to use Spearman rank and of course Kendall rank analysis. No, so in this case, if you wanted to know more about how to use the Likert data and to use other statistical methods, this will also be discussed to us in our next session or the last session, which is actually part 2. So this is part 1. Hopefully you gained some really good insights today. Also, if you are asking if this session is available, this session will be available at the UP Cebu TLRC YouTube channel. Just click on the live stream portion of the channel and you will see all of the useful recordings that we have for this session, and of course all of the previous session that UP Cebu TLRC had. Okay, and if you wanted to know more information about the activities and offerings of UP Cebu TLRC, don't forget to follow us at UP Cebu Teaching and Learning Resource Center FB page. Okay, let's start. Noel, okay na ba? Shall we start? Sir Joseph, okay ka na ba?
I think I can pick one question from the chat box.
Okay, sir. Let's have that in.
One question from YouTube.
There
Isn't
is
the
also
Kendall
some
rank-
question from YouTube, yes.
Yeah, thank you, ITC, which is one of the hosts, in parang copy pasting the comments or questions from YouTube. So there's one question from YouTube. Isn't the curl function used as a function for the Pearson R? Now for the curl function that I showed you using Excel, yes, you can use the curl function in getting your Pearson's R correlation coefficient, but the arrays that you are considering in the Pearson's R correlation coefficient that you want to, let's say, calculate are those, let's say, the raw data points from each variable. In Spearman correlation coefficient, the arrays that we are considering are the rankings. Okay, so from my example, the re-ranked ranks. Okay, so for Pearson R, you can use curl function, but the arrays are those the raw data points like a variable x, variable y. For Spearman rank correlation coefficient, the arrays that we are considering are the rankings.
Okay, so you have to remember on that. So rankings. Noel, can we have Sir Jax for the discussion? I know he is itching to answer some questions too. Sir Jax.
Hello.
And we have him in the discussion board right now. Also. Okay, Sir Jax.
Hello, good afternoon.
So let's have.
I've been answering questions since earlier. I'm like a
Yes.
chat support here.
This is the good thing about the
Answering
larger webinar. If you have some questions that are supposedly can be answered during the you can just chat it on. Okay, Sir Jax, what are the questions that you think are very interesting to answer live right now?
So there was a question that captured my attention. It was a question on how we can correlate, for example, variables with multiple representations. So for example, a variable x has sub variables like x1 to, for example, x10. So how do we make it how do we correlate it with another variable that has the same properties? So do we get the median or the mode first and correlate it? For me, sure, you can do it. So depending on whichever measure makes more sense in your research, kung median ba or mode. So just like what we have discussed last webinar. And then sure, you can use it to represent your variable X, to correlate it with your variable Y. Okay, it does not make sense to kung ang variable X, no, you have multiple, what do you call this, representations of that variable X. It's not practical to do a pairwise correlation, because they are just the same, since they are under one big variable and they are not independent per se. So it really is a good way to make it a compact using median or mode.
Okay, so everyone has to remember that, especially for the especially in using median or mode. Actually, there's one question kanina, sir. It's not necessarily question, but it was a comment that in using Bootstrap, basically, sometimes it's hard to use median. But it's all right, because as long as you don't use mean for ordinal data, especially in Likert analysis, so okay lang yun. How about you, Sir Joseph? Is there any question that you think is very interesting to answer right now and must be clarified? Kasi marami tayong questions ngayon.
And before I raise my questions to be answered by me, I just want to add to Sir Aboy's or Professor Aboy's comment about the comparison between two, let's say, distributions using the mean and the median. It's usually we use the median, right, for non-parametric tests like the Wilcoxon and the Mann-Whitney. That is for the dependent and independent samples, and then for Pascal-Wallis for more than two, let's say, groupings.
Yes.
Now for the mode, I think Minot in 1997 started her study about comparing different, let's say, groupings using the mode. And that was a parang, let's say, improvisation or improvised version of the study of Silverman in 1983. But there is still no fixed na test using the mode in comparing two distributions. However, nowadays, since we have now high, like, statistical software like Python and R, I think there are now tests that are being programmed or that has packages now in R and software that can compare to groupings using the mode, but very common in median. Okay, just to add to Professor Aboy's comment. And for the interesting questions, I think one might ask, how about if the sample sizes are not equal?
Yes.
For example, if we have a specific population, then males are larger. I mean, the number of males are larger than females. Now, in correlation analysis, the basic concept of correlation analysis, we have here the Pearson, Spearman, Kendall-Stowe. The basic concept is that we correlate one, let's say, data point to another. So if the sample sizes are not equal, then we cannot do correlation analysis. We can actually use non-parametric tests to compare the distributions. So for example, in non-parametric tests, like what I have mentioned, the Wilcoxon, they are not really very strict with the assumptions of normality, homogeneity, and equality of sample sizes, because again, they are non-parametric tests. So we can use that. So for correlation analysis, we cannot use unequal sizes of samples.
Okay, so always remember, for those who wanted to look into those variables with unequal distribution of samples, always make sure that you test for your samples or your data, whether it can be parametric tests or non-parametric tests should be used for that. Okay. I think that is mostly one of the problems, because some researchers, especially the young ones or those who are not yet really well versed in the statistical methods that they are using, somehow they use parametric tests for data that is supposedly non-parametric. So be very wary of that. Okay.
Yeah.
So
Adding to
yes,
what Ma'am Jara said, so if you really want to have a comprehensive analysis, but Likert data is inherently non-normal because it's categorical, it's ordinal. But if you really want to have a comprehensive analysis, so you can include in your diagnosis any normality test like Shapiro-Wilk test or Harkey-Bera test for normality. But there really is an infinitesimal probability that a Likert data is normally distributed because again, it is inherently non-normal in theory.
Okay, so take note of that, my dear participants and attendees. Okay, so we have new insights regarding those matters, things that are usually not so taken into account sometimes when we are getting fast into our research. Okay, let's have another question. So there are actually, yes, po. Were you able to have?
There is one question that has been repeated by a few respondents. How small is small? What is the appropriate sample size? That is a very, very good question. There is a paper by Bonnet and Wright published in 2000. So the paper, the, the the title of the paper is Sample Size Requirements for Estimating Pearson, Kendall, and Spearman. So you can check it out. It's a journal in Springer, so we know it's legit. So the journal name is Psychometrica. So you can check it out. It's a very good paper by Bonnet and Wright in 2000.
Okay, so kindly check that paper out if you wanted to learn more about that. Okay, Sir Joseph? There is one question here. Actually, it's coming from VCAA. VCA. Based on the demo, I must say that Jamovie is very easy and convenient to use. However, may I just clarify regarding the value? I think she was actually looking into the value that we were using kanina. The value of each of the questions. Does the value signify sa Cronbach's alpha of a particular question, or is it interpreted as the following? If that particular question is removed, will it improve the total Cronbach's alpha to 0.882? That is in question number 2. Kanina.
Okay, I think she was referring to the backward selection of the items, the one that I showed you. That is one way of checking if, for example, if you want to, let's say, drop one item, will this affect the reliability of your questionnaire? And that is just parang checking the items. But for the Cronbach's alpha, the reliability of the entire questionnaire, you have to consider the first one that I showed you. That is the Cronbach's alpha for all the items. 1 to 13 items. So for the other one, the second one that I click on Jamovie, that was just one way of parang checking if you have items that are really affecting the reliability of your questionnaire.
I see.
I hope that I answered the question.
Okay, so there are various ways to determine whatever points or functions are actually affecting currently your data. There's another question. Could you explain why Likert scale data, in contrast to Likert data, can be processed using traditional descriptive statistics, for example, mean, SD, and so on? So explain why Likert data, in contrast to Likert scale data, in contrast to Likert data, can be processed using traditional descriptive statistics. And are there instruments that are Likert type or Likert data and has user manual, which the measure of central tendency is mean? I think magre-react si Sir Jax dito.
Before Sir Jack would answer the question.
Regardless if it's Likert type, Likert scale, whatever you call it, it's still ordinal at the end of the day. So we cannot still use mean and standard deviation. So it's still median or mode.
Okay, just to add up to what Professor Aboy just said, in statistics, we are more concerned about the numbers, right? Like the data is considered as numbers. Now, for our purposes, we treat these numbers are as we have two properties of these numbers. We have measurement and counting. Okay, for the measurement, we have three identities. We have three properties: the identity, the ordering, and the additivity. Now, for the four levels or the four scales of measurements that was discussed by Professor Agustin last webinar, we have the nominal, ordinal, scale, nominal, ordinal, interval, and ratio. Now, for the nominal scale, it only has one property, that is the identity property. Okay, and for the ordinal scale, it has now two properties, the identity and the ordering. Okay, ordering property. For the interval, it now has the identity, the ordering, and another one is the equal distance. Okay, between the two. Let's say sample points, and then for the ratio, which is the highest level of measurement, it now has the absolute zero property. So when we say Likert data being applied to, let's say, parametric test and getting the mean, the standard deviation, you have to bear in mind that in statistics, we have two areas, the qualitative and the quantitative area. For the qualitative area, we're considering discrete variables. Discrete meaning we have gaps or interruptions between the different points. Now, for the quantitative area of statistics, most of the time, we are considering continuous data. Continuous meaning there are no gaps in our data. We're considering actually interval and ratio scale na data. So how can you apply the quantitative area of statistics in your ordinal scale data if that data is under the discrete data, which is under the qualitative area of statistics? No? So parang mahirap ipilit. Yun lang.
Okay. So, mahirap ipilit. So, always remember before starting off with your statistical analysis, always make sure that you know what data are you looking at. So, what kinds of measurements or what kinds of data are you looking at? If it's continuous, non-continuous, always remember you have to look into those before starting off looking into your data or statistical analysis. Okay.
So what Ma'am Jera is saying is it's like there are diagnoses that you need to do first before you perform your major analysis. So we call this diagnosis test. So just like what Ma'am Jera said, you first identify the level of measure of your variables. Next, you actually have to identify if the variable is normally distributed or not. So based from these results, you can now proceed. You can now choose what appropriate measure to use.
Okay. So, I think hindi natin ma-answer lahat. We're actually running out of time. Am I right, Noel? It's already 3:53.
Yes.
Sir Joseph and Sir Jax. So, unahin natin Sir Joseph. Sir Joseph, ano po yung gusto nyong i-remind sa ating mga participants with regards to what you have had discussed today? Yung pinaka-importanting points.
For my talk this afternoon, I was assigned to the first part of some inferences being applied on Likert data scale. No? So I focused on the correlation analysis. In correlation analysis, the main goal of this analysis is to examine the linear relationship between two variables. Now, since we are focusing in the Likert scale data, then we cannot use the famous Pearson R correlation coefficient. We use the Spearman's rank correlation or the Kendall's tau if we have small sample size and many tied ranks to do our, let's say, association analysis. So that is the main goal of my talk, to really avoid using the Pearson's R correlation coefficient in ordinal data. And then for the second part and the last part of this webinar, which will be discussed by Professor Aboy, it will focus more on the comparison of two groups, or for example, more than two groups, okay, in ordinal scale. So correlation analysis, it's very important, and avoid using Pearson's R in ordinal data. And also for the workshop that I have to give you later on, I still have to give the link to the host muna before the host can give to the participants for your completion certificate. Thank you.
Okay, so don't forget, okay, for ordinal data like the Likert data that we have right now, always remember you cannot use Pearson R. Okay, so we have Kendall and we also have Spearman for that. Sir Jax, last reminder, pasabi.
Okay. Siguro really the takeaway here is we really should know what appropriate tool to use if our data is like this. So we cannot just use any traditional just because it's popular. No, so at the we really should use appropriate statistical tools, and that should be based from the nature of your data set. Now in this talk, we are talking about Likert, Likert data or ordinal data. So that's why we, Sir Joseph discussed about Kendall and Spearman. And in my talk, hopefully you will still be here next week. I will be talking about inferences and determining whether or not two groups have the same distribution. So it really has a profound implication, let's say in education or in psychology. So tune in.
Okay, so those are the thoughts of our speakers and reactors today. Wala si Sir Agustin, ano? Sir Rad. Hopefully, nandito siya next. Para apat tayo dito.
He's actually
Okay.
here beside me.
Oh, pero hindi siya naka-Zoom. Hi, Sir Rad. Oh, hi, Sir. If you can still remember, Sir Rad is actually one of our speakers from the last session. Okay, now let's move forward. So moving forward, let's have the math and stat program AVP. So Noel. Okay, thank you so much for that, Noel. So we are actually promoting also our math department, especially our BS Mathematics program. Our BS Mathematics program is actually producing a lot of graduates that are now in various fields, including computer science, data analysis, marketing, and even in business and medical sciences. So basically, math rules the world. Now, for the giving of certificates, this certificate of recognition is proudly given to Sir Joseph P. Abordo for sharing his invaluable time and expertise as the resource speaker in the webinar Inferences on Likert Data Part 1, today, March 1, 2023, signed by our dearest TLRC coordinator, Miss Nati Estelioret. Okay, so before we start our ways and evaluate, let's have a little bit of photo op. Makaka-photo op pa ba tayo, Noel?
Wala na, miss, because hindi natin makikita yung participants.
Oo nga, that's the drawback of the webinar type, no? However, if you are still here with us, I know that there are around 700 individuals here with us at Zoom, and I don't know yet how many of them are in YouTube. Please make sure that you remember all of these reminders for evaluation. Our evaluation and processing of e-certificates are always automated. Please make sure to type in the correct spelling of your name, since this will reflect on your e-certificates. Also, please be mindful in typing your email address, because it is where you will receive your certificates. We suggest that you keep a copy of your responses in the evaluation for you to verify if you have made mistakes. Always click "Send me a copy of my responses" before submitting. Normally, it takes less than 3 minutes after submitting to receive your certificate. Should you not be able to receive it by 5 p.m. today, just send a reply message with your concern to the confirmation email that we sent, lrc.upcebu@up.edu.ph, and we will manually send the certificate on the next working day. Thank you very much for being here with us. And take note that the evaluation link is open for only 10 minutes. So kindly click on the link right now and evaluate. Before we end this webinar, kindly make sure that you also register on our next webinar. That's next week on March 8, 2023, still at 1:30 p.m. Inferences on Likert Data, that is part 2, and this will be delivered to us by our beloved mentor and Professor Jax Aboy. So I'm so happy that everyone is here with us, and I'm also very happy it's a good Wednesday today. Sir Joseph, thank you so much for being with us. And congratulations for a successful run today.
Thank you, Sir Joseph and Sir Jack.
Sir Jax.
So, Miss Jera, thank you.
Thank you.
Thank
Thank
you.
you sa inyo tanan.
Thank you.
Miss Jera, Sir Joseph, and Sir.
For those who are watching at YouTube, kindly wait for the signal of Miss Noel for you to come in and have the evaluation. Also, if you wanted to revisit all of the sessions of TLRC's learning series since 2021, try to go back at the UP Cebu TLRC YouTube channel. Kindly subscribe there. Subscribe. Click that subscribe and learn with us. Okay.
Thank you.
Thank you so much, everyone.
Yeah.
Okay. Also, shout out to VCA Hazel Trapero. Hey. She actually had a question kanina. So we had catered her question. So hi, Miss Hazel. Hi. Okay, so tingnan natin kung meron pa ba tayong dito.
So
Si Miss
again,
Hazel.
YouTube Live, you have YouTube Live audience. You have to get in the Zoom meeting, Zoom webinar if you have registered in order for you to evaluate and receive your e-certificate.
Okay, so let's YouTube Live participants kindly wait for the go signal of Miss
Ah.
Noel?
They can enter, Miss. We have a lot of
They can
room.
enter na already.
Yes.
Okay, you can enter now at our Zoom webinar. Those coming
Ah.
from our YouTube live.
Yes.
Hi, Sir Dems. Andyan si Sir Dems. Oh.
Ano si Sir Dems?
Hi, Sir Dems.
No.
Hi, Sir Dems. Ma'am, the evaluation link daw is not working.
I'll try to reshare the link, a different link na lang
Oh,
para easier.
okay.
Resharing the link right now, currently. Okay. I'm seeing a lot of Master of Education students here. So I think some of them are actually interested in education, education research and analysis. There's a lot of of Master of Education students here. I'm seeing names.
Good. I
Very
hope that
good.
they will apply. They have learned in their culminating requirement, which is the SP.
Yes.
Because I might sit as
Sir Jimboy is here. Hi, Sir Jimboy. Kumusta dyan?
Okay, nota.
The other link for the evaluation is shared in the chat. So that forms.google. Yeah, that's working now.
$584 na lang lagi.
Ulan. Happy start of Women's Month. Buwan ng mga kababaihan. Okay. Okay, so I'm hoping that everyone were able to access the link already.
Yes, marami na naka-access, Miss Jen.
Okay, very good.
Thank you very much.
Thank you very much for your patience. Shout out tayo kay Mike. Hi, Mike. Shout out sa mga nandyan sa Cebu nga.
Muted Travis. Muted si Miss Nati.
Miss Nati.
Muted ko, sorry. Hi,
Shout
Sir
out, Miss
Mike.
Nati.
Hi, Sir Mike. Basta. Thank you, Sir Joseph, Sir Jack.
Thank you, Sir Joseph, Sir Jack. And then Sir Rad po, nasa kilid. Sir
Rad.
Okay, so appeal na si Sir Rad ka next meeting. Si Sir
You
Joseph.
Required. Complete ang team. Hi.
Ayun. Naatay taga UP Cebu ng mga staff. Nakakita ako.
Yes, Miss. Ako gi-share din lang na attend.
Oh,
Okay.
that's nice.
Shout out sa mga taga UP Cebu. Biskan wala ko sa UP Cebu karon.
Taga UPLB, wag ka.
Taga from Cebu to Los Baños real quick. Cebu to Los Baños real quick. Pero murag ako kung nasa Cebu, Ayan. Daghan kayo sila karon. I'm so happy to see a lot of names that I know. Meron ka. Ay, okay. Sir Greg, hi po. Sir Greg from
Greg Loret?
UP Rural High.
Ah,
Okay.
yes.
Ayan. Miss Nati, ba sinakay gusto na shout out?
No, wala lang.
Wala
Shout out
na.
to everyone who have participated in this webinar. Hope to see you again next time. Ay, there. Yeah.
Hope to see you on March 8th.
Yes.
Okay, for those who are still new, kindly make sure that you look at the chat box. The evaluation link is there. Okay, and also make sure that if the Google form would require you to log in, kindly log in. Okay.
Hi, Sir Jack. May pahabol na sa ate. Do you have something more to say?
May pahabol ba,
wala
Sir
ba?
Jack?
I just want to say, I hope that they will all tune in my talk next week.
They surely will.
They will surely be there.
Yes.
We have very huge number of participants today. We actually reach around 780 in the Zoom itself. I don't know how many are they at the YouTube channel. Okay. So, congratulations for a very good run, Sir Joseph. No, nakakita na sila ng kagwapuhan ni Sir Joseph. Inig ka next meeting. Inig ka next meeting ang kagwapuhan naman ni Sir Jax. You will be graced with Sir Jax kagwapuhan next session. Heartthrob yan. Kung tatlo, heartthrob to sa math department. Diba? For sure, Sir Rad pa lang daan. Okay. Naghanag interesting na question karon, Sir Jax pa.
Nagta-technical ang questions, which is good.
You see?
Yeah.
The TLRC fans club and members are very
I
intellectual. We love them so much, and that's the reason why we still continue doing this.
Actually,
We
Ma'am
love it,
Jera, the next the continuation of this is already modeling. So yeah. So we can model now these Likert data as dependent and independent variables, and we can measure if they impact one another, if there is a causality that happens. So we'll see if we can. We
Okay,
can have
baka
that.
mas interesting may causal na.
Yeah, it really is. It's more profound. It has a more meaningful
True.
concepts. So we'll see.
We'll see. Miss Nati, marami pang nakaabang na series after this, no? Few more series after
We're
this.
still looking for volunteers or speakers. These are speakers.
Some new concepts rin at saka topics for learning.
Management.
Currently
Hopefully,
also,
management.
the high school is conducting their how to make research.
Congress. Yeah. CI Congress.
Sa CI Congress. Kasi yung mga high school sa UP Cebu, parang college kung makadala ng research. Oo. Currently, today, I think, today ba yun, Noel? Or this week?
3 Miss.
Okay. On March 3, if you can check on the CI Congress of UP Cebu Facebook page, they will have a webinar. It's a high-flex webinar on how to conduct focus group discussions. So this is on data gathering. So they have that, how to conduct focus group discussions. Our high school students at UP Cebu are very focused on their creative investigation and research work, actually. So some of them were working on sciences and some of them are working on social sciences and politics topics that are very, very important nowadays. So this only shows that you can be a researcher at any age. You just have to learn how to do it and use the correct and sound research protocols. Okay, so if you wanted to know more about how to conduct FGDs, kindly make sure that you look into the CI Congress page of the UP Cebu High School. I think the information is also at the TLRC page. Am I right, Noel?
Yes, Miss, it's shared in our page. So access na nila.
Yes. Okay, so you can access over there. There's a lot of avenues for learning. Okay. Okay. Kindly check your online login for Google if you cannot open the link or the link isn't working. There's a new link over here at the chat box. Kindly check if this link is already working. Okay. Okay, kindly make sure that you check if the link is working. Okay, the link is currently at our chat box right now. So if you're coming from the YouTube live, you just came in, kindly check the chat box. Okay, if you did not receive a certificate currently as of the moment, kindly wait until 5 p.m. today. If the certificate is not yet there, kindly email us directly so that we can manually create the certificate for you. Okay, some has already got their certificates. The registration for next week's part 2 will be available at the TLRC Facebook page. Okay, so I think the registration is will be commencing this week or end of this week. Okay. Noel, I think the link is not working for some.
Should I set the long link na lang? Longer one?
I think you should click on the longer link currently being shown here at our chat box. Okay, some of them already got the certificate. That's good. That's good. Thank you so much for being with us. Thank you so much also for always joining us. Without all of you joining, we cannot continue offering these free and useful webinars. We always hope to deliver cost-free and borderless learning for everyone.
Yeah.
Okay, so if you were not able to receive your certificate after submitting your link, the evaluation, kindly make sure that you email us through lrc.upcebu@up.edu.ph. I'll be putting here the email that you need to send it to. Okay. So